Good afternoon, friends. Welcome to my channel Computer Science Corner. Today I will be giving a basic lecture on data structures and algorithms. So let me write the name of the topic: data structures and algorithms. Pardon me for my handwriting, it is not very good. So basically I will be covering data structures in a separate playlist in my YouTube channel. But this playlist will be specifically based on algorithms. So the number one point is, what do you mean by an algorithm? I mean, you may be familiar with this term algorithm, but many of us don't know what it actually means. So what do you mean by an algorithm? So let us consider the problem of preparing an omelette or any other dish. If I take the example of an omelette, then for preparing an omelette, the general steps that we follow are: number one, maybe getting the frying pan; number two, getting the oil. Then we just check that do we have oil. If yes, then we put it in the pan, and if we don't, then do we want to buy an oil from a shop? If yes, then we go out and buy the oil and then come back in our kitchen and then do the rest of the proceedings. And if not, then we continue with our preparation of an omelette. Okay, and then the corresponding steps are turn on the stove, etc., etc. So what we are doing is that for any given problem, just as in this case, that is preparing an omelette, we are giving the step-by-step procedure for preparing it or for solving it. So the formal definition of an algorithm may be written as: an algorithm is the step-by-step instructions to solve a given problem or a particular problem. To solve a given problem. I hope up to this point it is clear to you. Okay. Now come to the second point, that is why we perform analysis of an algorithm. I mean, there can be many algorithms, but the main fact is that depending on the analysis of a particular algorithm, we may categorize it to be a good algorithm or to be a bad algorithm. Okay, so suppose we have one problem. So suppose we have two cities named A and B respectively, and we need to do a journey from city A to city B. Now there can be many modes of transportation which we can take in order to move from city A to city B. It can be bus. We can go from A to B by bus. We can go there by train. We can catch a flight, and many other modes of communications. Okay, now the point is, different modes of communication will require different amount of time to go from city A to city B. So our perspective of doing this analysis will be to select that mode of communication which will require the least amount of time in order to reach from A to B, be it bus, be it by train, or be it by flight. Okay, so algorithm analysis helps us in determining which of them is efficient in terms of time and space separately. So therefore, under the analysis of an algorithm, we basically perform time analysis, which we also known as time complexity. That means finding out the complexity of the time needed by a particular algorithm. And then we do space complexity analysis or space analysis most accurately. Okay, so these are the two main parameters based upon which we declare an algorithm to be the best one or to be an worst one. Now coming to the third point is goal of analysis of algorithm. Goal of analysis of algorithm. What will be our goal? The goal of analysis of an algorithm is to compare the algorithms or the solutions which are mainly in terms of running time but also in terms of other factors like memory, developers, effort. See, here we have mentioned 2 points, that is in order to perform the analysis of an algorithm, we mainly refer to two metrics, that is time and space. But beyond their scope, there are other parameters also based upon which we can perform analysis of a particular algorithm, and they are mainly memory requirement, or it may be similarized as this of space. Both these terms are equivalent to each other, that is memory. Number 2 may be developers, and so on, etc., etc. Now the fourth point is running time analysis. Running time analysis. The running time analysis means it is the process of determining how the processing time increases. That means time in case of processing, it increases with the size of the problem. This is the size of problem. So how these two are dependent on each other. That means if we increase the size of the problem, then how much time will the algorithm take in order to complete its execution, and if we decrease the size of problem, then also how much time will it take to complete its execution. So we need to find out the main dependency factor between this time and the size of the problem. The size of the problem is also known as input size. You may have come across these terms in many books or in video lectures like these. Okay, so this is also known as the input size. So the input size is nothing but the number of elements. The input size, it is nothing but the number of elements, in the input. I mean, if we are performing, say for example, we are performing a sorting algorithm on an array or on a given array, then the number of elements of the array or the array size is also known as, will be in that case the input size of the problem. Okay, and we encounter the following types. There may be different types of inputs in a particular problem. It may be size of an array, polynomial. Please note down these terms as I am not writing it explicitly in my copy. The different types of inputs may be the size of an array, polynomial degree of an quadratic equation, number of elements in a matrix. A matrix means nothing but a two-dimensional array. You are familiar with it as we have done in mathematics. Then another type of inputs may be the number of bits in the binary representation of the input, and specifically in terms of graph problems, the number of vertices and edges may be the different types of inputs. Okay, now how to compare the algorithms? In order to compare the algorithms, we mainly do it. There may be many factors depending upon which we can compare two given algorithms. The most used parameters are execution times. Let me write it down. It may be execution time. I mean, for how much time does a particular algorithm executes. Okay, and this is the first one, and the second one may be the number of statements executed. The number of statements executed. Now, these two particular factors are not a good measure of are not a good are not considered to be a good measure of comparison of algorithms. Why? Because let us come to the first point, that is execution time. It is not a good measure since the execution time are specific to a particular computer. That means if you are using a Pentium 4 processor, and if suppose say for the same problem I am using suppose i7 or i5 processor, then the execution time will vary a lot in both the computers for the same problem. That means if say suppose if I am performing a sorting algorithm on a given array, then the processor, that is the Pentium 4 processor, may take a much amount of time in comparison to that of the i5 or i7 processor, which will take a much significantly less amount of time. So therefore the execution time, which is measured in clock cycles, is not a good choice for comparing two algorithms. Okay, now coming to the second point, that is the number of statements executed. Now this is also not a good measure. Why? Because the number of statements varies with the programming language that are being used by the programmers, as well as the style of writing a code by an individual programmer. That means suppose suppose there are two programmers particularly running a simple algorithm. Let's say programmer A uses Java, and let's say programmer B uses Python as their programming language. Now we all know that since Java uses long syntaxes as compared to Python, so therefore it is obvious that the same code written in, or the same algorithm written in Java will be lengthier than the same algorithm or the code written in Python. So therefore again the number of statements of a code is also not a good measure to compare two algorithms. Then what will be the ideal solution? What will be the ideal solution? The ideal solution is that let us assume that we have expressed the running time of a given algorithm as a function of the input size. That means suppose if I say that the running time is t of an algorithm, it will be expressed with respect to n. That means where n is the input size. N is the input size of the problem. Okay, just as I have mentioned it previously. So we need to find out this Tn. This Tn needs to be found out for algorithms say A and B. Then we will compare between the Tn of these two algorithms. Clear? Now this kind of comparison is mainly preferred because it is independent of machine time and programming style or the number of statements executed, etc., etc. That means it is independent of all the irrelevant metrics that was previously supposed to be the metrics of comparing multiple algorithms. Okay, so this is all for today. In the next video I will be talking about the rates of growth and the types of analysis that are being mainly done in order to compare two algorithms. Till then, have a good day and stay safe. Goodbye.